about 127 million years ago. This environment is understood to be a fluvial or mudflat setting characterized by shallow waters, lagoons, and marshes. In the early Cretaceous period, the southern region of England was partially submerged under the Weldon Lake, which had fresh to brackish water. Two significant rivers flowed from the northern area. The climate during this time was subtropical, akin to that of the modern Mediterranean region. Polacanthus, a herbivorous nodosaurid. Polacanthus was a medium-sized ankylosaur. In 2010, it was estimated to be 16 feet long and weigh 2.2 short tons. However, another paleontologist provided a lower estimate of 13 feet and between 500 and 1,001 pounds in 2012. Its hind limbs are comparatively long for an ankylosaur, with the holotype right femur measuring approximately 21.9 in length. In 2011, two distinct unique traits, known as autapomorphies, were identified. The floor of the neural canal is significantly carved by a groove that has a V-shaped transverse profile. The caudal spikes exhibit triangular bases when viewed from the side and have narrow tips. In 2020, research determined a singular autapomorphy. The ischia curve towards one another at half their length, with their rear ends meeting at their inner sides. The subsequent researchers have consistently invested considerable effort into reconstructing the configuration of the armor. It has been recognized that Polacanthus possessed a substantial pelvic shield, or sacral shield, which is a single fused sheet of dermal bone covering its hips, sacral region, that may not have been directly attached to the underlying bone and was adorned with tubercles. This characteristic is also found in other polacanthine, basal nodosaurids, dinosaurs like Gastonia and Mimurapelta. The holotype shows that this shield measures 108 centimeters in width and 90 centimeters in length. It displays four horizontal rows of larger keeled osteoderms on each side, encircled by smaller ossicles. These latter elements are occasionally entirely fused to create flat armor plates. It was believed that there were two rows of keeled osteoderms on each side of the tail. Regarding a collection of spikes discovered alongside the fossil, it was presumed they adorned the sides of the rump. However, another paleontologist proposed a different configuration. They suggested that both the tail and the front of the body, including the neck, had two parallel rows of spikes, one on each side. Each row on the front body was thought to contain 5 spikes, and it was claimed that 7 of these had been preserved with the fossil, 5 from the right side and 2 from the left. The tail rows were estimated to have consisted of 22 shorter pairs, with 15 spikes still present, 8 on the left side and 7 on the right. Given the asymmetrical nature of the spikes, their arrangement can be inferred to some extent. In 1987, Blows largely concurred with another paleontologist but also identified 3 types of spikes, type A, B, and C, which enabled them to categorize additional fossil discoveries that often varied from the holotype spikes in various aspects. Polacanthus fossils have been found in England and Spain. The name Polacanthus translates to many spines in ancient Greek. It comes from the Greek terms polys, which means many, and acantha, which signifies thorn or prickle. This designation highlights the abundance of bony plates and spikes that adorn the dinosaur's back and sides. A variety of other specimens from White and Great Britain have since been classified as Polacanthus. These primarily include individual bones or armor fragments. Several specimens discovered before the holotype were at different times thought to be associated with Polacanthus. In 1843, it was noted that 3 such specimens were found on White, consisting solely of armor pieces. Unfortunately, they were already missing before the description was published. In 1859, a geologist noted that his collection contained many scuds, spikes, and vertebrae from White, which he attributed to Hylaeosaurus. After their passing, the collection was relocated multiple times, resulting in the loss of these pieces. Baryonyx, a piscivorous spinosaurid. The baryonyx skull is not fully understood, with much of its middle and rear sections missing. It is estimated that the skull measured around 36 to 37 inches in length, drawing comparisons to the related genus Suchomimus, which was 20% larger. The skull was elongated, featuring a long, narrow, and low snout that measured 6.7 inches at the front of the premaxilla, characterized by a smoothly rounded upper surface. The bony nostrils were elongated, low, and positioned far back from the tip of the snout. The front 5.1 inches of the snout flared out into a spoon-shaped, terminal rosette, resembling the rostrum of the modern gharial. The lower margin of the premaxilla was downturned or hooked for the first 2.8 inches, while the front part of the maxillae was upturned. This unique morphology created a sigmoid or S-shaped contour in the lower upper tooth row, with the teeth at the front of the maxilla protruding forward. The snout was particularly narrow just behind the rosette, an area that accommodated the large teeth of the mandible. The maxilla and premaxilla of Baryonyx interlocked in a complex manner, resulting in a gap between the upper and lower jaws known as the subrostral notch. A downturned premaxilla and a sigmoid lower margin of the upper tooth row were also observed in distantly related theropods. The snout featured numerous foramina openings, which likely served as exits for blood vessels and nerves, and the maxilla seems to have contained sinuses. A 2023 study conducted by paleontologists, utilizing CT scans of baryonyx brain cases, revealed that the brain structure of these baryonychemes closely resembled that of other non-maniraptoriform theropods. Their neurosensory abilities, including hearing and smell, were found to be quite average, and their gaze stabilization was not as advanced as that of spinosaurines. Consequently, their behavioral adaptations likely mirrored those of other large terrestrial theropods. This indicates that their evolution from terrestrial hypercarnivores to semi-aquatic generalists did not necessitate significant changes in their brain and sensory systems. Baryonyx fossils have been found in England and Spain. The term baryonyx is derived from the Greek words baros, meaning heavy, and onyx, which translates to claw. This name highlights the dinosaur's notable large claw on its hand, key characteristic that sets it apart. Baryonyx's ulna featured a robust olecranon and a broadened lower end. Its hands consisted of 3 fingers. The first finger showcased a sizable claw, approximately 12 inches long along its curve in the holotype specimen. In life, this claw would have been elongated by a keratin sheath. Besides its size, the claw's proportions were quite standard for a theropod. It was bilaterally symmetrical, slightly compressed, smoothly rounded, and sharply pointed. A groove for the sheath extended along the claw's length. The other claws on the hand were significantly smaller. The primary hip bone of the pelvis displayed a notable supraacetabular crest, a slender anterior process that was vertically expanded, and a long, straight posterior process. The baryonyx are a duo of boisterous predators on the hunt for a meal. Fortunately, they stumble upon the group of Polacanthus. Although the Polacanthus lack many offensive body features, they are relatively well equipped for defense. This Baryonyx exhibits signs of desperation as it attacks a heavily armored herbivore. This behavior may stem from a scarcity of food in its original habitat, prompting it to seek sustenance elsewhere, which could pose a threat to the broader ecosystem.